Hey YouTube, what's up, it's Link. Welcome back to another episode of Coding Session. And this video was actually supposed to come out way before my other binary tree episodes, but I guess I accidentally didn't upload it, so I'm redoing it now. So this is a problem on Leetcode, which is Invert Binary Tree. It's an easy difficulty problem, and it simply asks for you to invert the binary tree. It's inspired by a tweet from a developer by the name of Max Howell, and the tweet reads, Google, 90% of our engineers use the software you wrote, Homebrew, but you can't invert a binary tree on a whiteboard, so F off. So before I continue, I'm going to admit that I myself have not been involved in a full-on technical interview. So if I'm handed a marker, I'm asked to go up to the whiteboard and write some complex algorithm or implement some data structure to solve a complex problem. I guarantee you I will choke. I'm really bad with, I'm especially under pressure doing these sort of complex problems, using data structures and algorithms and implement them to solve complex problems and whiteboard problems such as these, which is, I'm really bad at it, which is why I changed the overall atmosphere or feeling for these series of videos, the coding session series of videos. They're more focused on programming concepts, algorithms, and data structures. So I'm also not only just kind of teaching myself, but also along the way teaching other developers as well, and explaining these algorithms and data structures and concepts in the best way I can. So if we look at the example, you'll notice that the left nodes and the right nodes are swapped from it. This is the original and this is the output. So starting from the root all the way down to each subtree, into each children of each root, all the way down to even the leaves. Pretty much the whole tree is inverted. And how this works is, we'll notice in the output, obviously 4 stays the same, that's the top root. Inverted 4 is 4. And then we start to go to our left and right nodes, and you'll notice that 2 and 7 are swapped. And if you go down to their children, this subtree, you can see my cursor, yeah, you can. And this subtree, you'll notice that the numbers are swapped as well. This was 2 and 7, this is 7 and 2, and here it was 1 and 3, now it's 3 and 1. This one was 6 and 9, and now it's 9 and 6. So how do we implement this? How do we solve this problem? Well, with the difficulty that it is, which is easy, and from hints from the inspired tweet, this is a very easy problem. So if you watch my previous binary tree videos, when I go over the algorithms involved, such as the traversals, in order, pre-order, post-order, depth first search, breadth first search, searching for a node in a specific tree. By the way, when it comes to depth first search and breadth first search, I do have a depth first search video already recorded, and I actually go over an application used for it. So that's a very special video. Stay tuned for that. As far as breadth first search, we'll go over that in a future episode. But all these algorithms involve the binary trees. You'll notice that we take advantage of the power of recursion. And most examples you're going to see online, most algorithms that involve manipulating a binary tree are going to be recursive. Recursive is very, very powerful when it comes to binary trees. So first off, when it comes to since we're implementing a recursive algorithm, we need a base case. So if root is equal to null, simply return null, because a null binary tree, a null inverted binary tree, a null binary tree is an inverted binary tree. Then we'll create 2 object references of tree node. Right is equal to invert tree root.right, and a tree node left is equal to invert tree root.left. And now all we simply have to do, still spelled tree node wrong for the left object reference. So all we have to do now is just do root.right is equal to the left. Literally, you're going down through each root, each subtree's root, through each tree node's left tree node and right tree node, and you're just swapping them, flipping them. That's it. Here's the 4, here's the 4, here's the 2, here's the 7. Now it's 7, 2. Go down to each subtree. So on the 7 side, 6 and 9. Now 9 and 6. On the 2 side, which is 1 and 3. Now it's 3 and 1. So root.right is equal to left, and root.left is equal to right, and simply return root, and then let the power of recursion just take over. So, yeah, sorry, I don't know why I paused there. So let's go ahead and run our code for the first test case. There we go. Let's submit it. And as you can see there, we've successfully solved the invert binary tree problem. Again, most algorithms that involve manipulating a binary tree, especially if you're just, learning online, just learning stuff online, looking at resources and whatnot, they're going to take advantage of recursion. And recursive is very powerful when it comes to binary trees. It really helps out when writing these complex algorithms to manipulate a tree in however way you want. So literally, go through the entire tree, each root, each root's tree node, right tree node, left tree node. The right is equal to the left, left is equal to the right. That is it. So hope you guys enjoyed this video. If you need me to clear up any explanation or explain something further, leave a comment down below and I will try my best and get that resolved. So thank you guys for watching, and have a nice day.